Okay, so welcome to the chemistry assignment sheet 1 that we are solving tonight. Okay, so question 1 goes, the major air pollutant of coal burning contains only sulfur and oxygen. The chemical analysis of a 1.078 gram sample of this gas showed us that it contained 0.54 grams of sulfur and 0.538 grams of oxygen. What is the empirical formula of this compound? So the answer to this question is sulfur dioxide. Now you may ask, how do we get these answers? So as you learned in class, the first thing to do is to find the moles of oxygen and sulfur. So how do you find the number of moles? Number of moles is simply mass over relative molecular mass. So for oxygen, we've been given in the question and it is 0.538 grams and the relative molecular mass of oxygen is 16. You work out that calculation, you're going to find 0.033625. And then the moles of sulfur, you simply divide the relative molecular mass into the given mass of sulfur, which is 0.540 grams, divided by 32, which is the relative molecular mass of sulfur, and you're going to find 0.01685 or 75 rather. Okay, so between the moles of oxygen and the moles of sulfur, you find that the moles of sulfur are less. So here we divide both sides by the moles of sulfur. Here to give us 1. Then we divide 0.01685 into 0.033625. It will give us 1.99. You round off this, it will give you 2. Okay, and this here will remain 1. Forget about this 2 here, to remain 1. Therefore, the empirical formula is going to be S1O2. You write it like this, sulfur dioxide. So question 1 was really easy. Okay. When you go to question 2 read a piece of iron ore is found to contain a compound containing 72.3% iron and 27.7% oxygen with a molecular mass of 231.4 grams per mole. What is the molecular formula of this compound? So the answer here is this one, triiron tetraoxide, F3O4. How do we get this? So since 72.3% plus 27.7%, when you add them, they'll give you 100. You assume that 72.3% is 72.3 grams and 27.7% is 27.7 grams. Therefore, since you have the masses now, you can find the moles of iron and you can find the moles of oxygen. So number of moles as of before, you just divide the relative molecular mass into the mass. So for iron here, you find 1.30. For oxygen, you're going to find 1.73. So between the two, 1.30 is smaller. So you divide both sides by 1.30. For oxygen for iron to give you 1, for oxygen to give you 1.33. So now you seek to get this decimal number here close to a whole number, and the factor that you're going to multiply it with so that it gets you close to a whole number is 3. So you multiply both sides times 3 here, and even this side times 3. So 1 times 3 here will give you 3. 1.33 times 3 will give you 3.99. You round off this, it will give you 4. So the empirical formula here is F3O4. Very easy. All right. So question 3, well, I didn't write down the question, but it was saying an S chemistry student hits a piece of iron metal in a crucible. The reaction is iron plus oxygen gives you FX OY, and they say complete the data below. Determine the empirical formula of iron oxide. All right. So the mass of the crucible was this. The mass of the crucible plus the iron was this. Therefore, the mass of the iron was this. What you do is just subtract this from this. It will give you this. Mass of the crucible plus iron oxide was found to be this, and these other values I found and I completed the table. Now, interestingly, they were saying find the empirical formula of this compound here, iron X, oxygen Y. So first of all, as of before, you determine the moles of iron. We already found the grams of iron to be 1.13 grams. Divided by the relative molecular mass, it will give you 0.02. The moles of oxygen, we already found so already found the moles of oxygen here to be 0.03. Okay, divided by 16, the mass rather was 0.48, which is here. 0.48 divided by 16 will give you 0.03. So between the moles of oxygen and iron, the moles of iron were less, so you divide both sides by the moles of iron, which will give you 1 here. This will give you 1.5. So you are seeking to get this 1.5 to a complete digit. So you multiply it by 2. Here there will be 3. Here it will be 2. So this is the empirical formula here. Question 4 said, silver nitrate solution is added to 25 ml of a 0.5 molarity potassium chloride solution until no more precipitate forms. What mass of silver chloride will be formed? So you are reacting silver nitrate with potassium chloride. When you react that, you get silver chloride plus potassium nitrate. So first of all, what you do is you first calculate the moles of potassium chloride, which is just concentration of potassium chloride plus volume. So you've been given the concentration, you've been given the volume in mils. You convert that volume in mils, this volume here, 25 mils to liters, which will be 0.025 liters. You work out the math. The moles of potassium chloride are going to be 0.0125 moles. Now, the mole to mole ratio of potassium chloride and silver chloride is 1:1, meaning that the number of potassium chloride moles is equal to the moles of silver chloride. Okay, so the number of silver chloride will simply be 0.0125 moles. Since we know the number of moles, you just plug in the number of moles into the formula. You know how you calculate the mass of silver chloride is just equals to moles times relative molecular mass. The moles is 0. So I forgot a 0 here. It's supposed to be 0.0125 times 143.4, and it will give you 1.79 grams. So this is the correct answer, which were formed. So this is the number of grams that was formed of silver chloride when now silver nitrate and potassium chloride reacted. Question 5 says calculate the number of moles of copper sulfate contained in 100 ml of 1 molar copper sulfate solution. Calculate the number of sulfate ions in copper sulfate. So now here you just use logic. Here what you do is that in 1 mole of copper sulfate, there are 1,000 mils. Okay, so in 1,000 mils, 1 molar simply means in 1,000 mils there is 1 mole. So if there is 1 mole in 1,000 mils, it means that in 100 mils there's going to be 0.1 moles of copper. So just do the math. Just do the math. If there is 1 mole in 1,000 mils, how many moles are going to be in 100 mils? when you do the math, you find that 0.1 mole of copper sulfate will be in 100 ml of solution. And 100 ml of 1 molar copper sulfate solution contains 0.1 moles of sulfate ions in 100 ml of solution. Why is it the same? The number of moles for copper sulfate to that of sulfate ions, because when you dissociate this, the copper ions and the sulfate ions are going to be 1 to 1. Okay, so question 6. What volume of a 0.01 molar of sodium carbonate is required to neutralize 25 centimeters cubed of a solution containing 0.98 grams of sulfuric acid? So this is the reaction that takes place. So the steps: first, determine the moles of sulfuric acid. Okay, you've been given the grams, you've been given the moles, the volume of sulfuric acid. You know that concentration is just equals to moles over volume in liters. When you work that out, you find that the number of moles of sulfuric acid is this, 0.009991. Okay, now sulfuric acid and sodium carbonate have got a 1-to-1 relationship. So meaning the number of moles of sulfuric acid is the number of moles of sodium carbonate. So this is also the number of moles of sodium carbonate. Okay, so to determine the volume, you're just going to say volume is equals to number of moles over concentration, concentration, which is this one here. So you divide the concentration into the number of moles, it will give you the volume, which is 1 liter or 1000 ml. All right. Question 7. What would be the limiting reagent if 75 grams of that compound reacted with 50 grams of oxygen in this reaction here? So first of all, find the number of moles of this compound. So 75 grams, this is the relative molecular mass. These are the number of moles. The number of moles of oxygen in 50 grams is this. Okay. And then get the stoichiometric coefficient. So the stoichiometric coefficient of this compound is here. Divide into the number of moles, it will give you this. The stoichiometric coefficient of oxygen is 11. So divide 11 into the number of moles of oxygen. When you do that math for this compound, it will give you this. For oxygen, it will give you this. This value is less than this value, meaning that the limiting reagent will be this compound here. Okay, so this compound is the limiting reagent. So that's the general approach of how you find a limiting reagent. Question 8. Suppose 316 grams of aluminium sulfide reacts with 493 grams of water. What mass of excess reactant remains? So the first thing to do here is determine the limiting reactants. So first of all, find the moles of this reactant here, the aluminium sulfide, and the moles of water. So the grams have already been given. The relative molecular mass of aluminium sulfide is there. Divide into the grams, will give you these moles. For water, the grams was given. The relative molecular mass is 18. You find these moles. And then divide the stoichiometric coefficients into the number of moles. So for aluminium sulfide, it's 1 here, as you can see. So you divide this into 1, gives you the same value. For water, it's 6. So you divide the stoichiometric coefficient of water into this, it will give you 4.56. So you compare between 4.56 and 2.11. 4.56 is greater, meaning that aluminium sulfide is the limiting reactant. Okay, so now find out how many moles of water actually reacted. So you know that 1 mole of aluminium sulfide requires 6 moles of water. So it's 2.11 will require 6 times 2.11 moles of water. So these are the number of moles for water that actually reacted in this reaction. Okay, so the mass of water consumed would be these moles times the relative molecular mass of water, because you know that mass is just moles times the relative molecular mass. So the mass of water that was consumed was 227.88 grams. The mass of water that remained was the number of water that was given in the solution, which is 4.9, for 493 minus 227.88, which will give you this value. So this is our answer here. This is our final answer. Question 9. How many grams of IF5 would be produced using, let me just, okay. So how many grams of IF5 would be produced using 44.01 grams of I2O5 and 101.0 grams of BRF3. So this solution, this equation chemical reaction has been illustrated in this chemical reaction here. So first of all, you find the number of moles for the reactants, for this guy here and for this guy, to find out which one is the limiting reagent. So the grams for this compound has been given. This is the relative molecular mass after I calculated for this compound. And then these were the number of moles I found. For this compound, these were the number of moles I found. Stoichiometric coefficient for this compound is 6, so I divided and then I found this number. Stoichiometric coefficient for this compound is this, I divided, I found this number. Between this number and this number, this is smaller. So meaning this compound here is the limiting reagent. So now we use the limiting reagent to actually find the product. So the stoichiometric ratios between this compound and this compound here, which is our compound of interest, is 6 to 12. 6 to 12. You simplify it, it's just 1 to 2. 6 into 6, 1. 6 into 12, 2. Okay. The number of moles for this compound is this. So meaning I can find the number of moles for this compound. I just do the math. I find that the number of moles for this compound is this. Using the number of moles, I can find the mass for this compound using its number of moles and the relative molecular mass. So the answer to this question is 58.45 grams. Beautiful, isn't it? Okay, so for question 10, 11, and 13, we're going to do them in the next video. So for question 12, part A, the answer is 2.3 atm. I didn't show how I solved because the video would have been very long. For question 14, the answer for A is 263.7, and for B it is 223. All right. So this is the end of this video. Don't forget to subscribe because we'll be solving a lot of questions together to help each other in med school. We'll be revising question papers to get you prepared for the tests and for the exams. Comment, share the video link with your friends. Don't forget to like and comment. Bye-bye for now.